Hello everyone, and welcome to 11.9, Area and Volume of Similar Solids. So first remember that this symbol for similar looks like this, and similar solids are solids with the same shape, but they're going to be different sizes. So all of their corresponding dimensions are going to be proportional to each other. So like for example, we could tell that this, what looks like this prism, this one is a little bit bigger than the other, but it says given that they're similar, meaning that all of the dimensions are proportional. And so we know that whenever we have similar shapes, they have a ratio, and we call that the similarity ratio. So the similarity ratio is going to be A over B. That just compares the two shapes. And so since it's a similarity ratio, we can write it as the one on the left to the one on the right, or the one on the right to the one on the left. We can write it either way, so A over B or B over A. So what is the ratio of the surface areas? Well, if the similarity ratio of two similar solids is A over B, then the ratio of their surface areas is going to be A squared over B squared. So if you wanted to write that as a fraction, you could. That's going to be A squared over B squared for surface area. Easy to remember because area is always units squared. Okay. Well, what is volume? Volume is always going to be units cubed. So it says if the similarity ratio of two similar solids is A to B, the ratio of their volumes is going to be A cubed to B cubed. So you could also write that as a fraction, A cubed over B cubed. Easy to remember because volume is always units cubed. So the next set of directions say, given that the figures are similar, identify the following values. So we can only do this because it says that they're similar. And so because these are similar, we know that the similarity ratio is going to be A over B. Even though I don't have any dimensions on these pictures, I know that the similarity ratio is going to be A over B, the surface area ratio is going to be A squared over B squared, and the volume ratio is going to be A cubed over B cubed. So in class, we kind of talked about that, kind of like a video game. It's 3 different levels, to the first power, to the second power, to the third power. And they give you no dimensions on these shapes, but we do know that they're similar, meaning that their dimensions are going to be proportional to each other. What information they do give you is they say that the surface area of this shape is 144 meters squared, where the surface area of this shape, the bigger shape, is 324. So what piece of information does that go with? That goes with meters squared. That's going to be my surface area ratio. So that's going to be my A squared over B squared. We can fill in, that's going to be 144 over 324. Because it's a ratio, it needs to be fully reduced, so let's go ahead and do that. We're going to reduce it from the beginning so we don't have to reduce them at the end. That reduces to 4 over 9. So which level do I put that on? The similarity ratio, level 1, surface area ratio, level 2, or volume ratio, level 3? 4 over 9 is going to be my surface area ratio because I just compared two pieces of the surface area. Okay, so there's my surface area ratio. If I want to get my similarity ratio, that's going to go from A squared to B squared. And whenever you want to go from A squared to B squared, what you are going to be doing is you're going to be taking the square root. The inverse of squaring something is taking the square root. So that's going to be the square root of 4 over the square root of 9. So going from something that is squared to something that is not squared, you take the square root. So that's going to give me 2/3. That is my A and that is my B. So why does that help me unlock level 3, my volume ratio? Because now I know what A and B are. If A is 2 and B is 3, then my volume ratio is going to be 2 cubed over 3 cubed. 2 to the third power is 8, and 3 to the third power is 27. So all of these are fully reduced because I reduced that fraction at the very beginning, and there's all 3 levels. All right, let's look at our next one. Our next problem, they give me two shapes that are similar, it says in the directions, and it gives me a volume ratio. So let's start A over B. A squared over B squared is surface area. A cubed over B cubed is volume. So what information do they give us? Well, they give us volume. This is centimeters to the third power. And so the volume ratio is going to be A cubed over B cubed. We're going to plug in those pieces, 729 over 1331. You can check to see if that reduces at the very beginning. Just saves you time later. And it does not. And so we're going to leave that as the volume ratio, 729 over 1331, that is fully reduced. So if that is my A cubed and my B cubed, how do I go from A cubed over B cubed back to A over B? I'm going to take the cubed root of each of these pieces. So it's going to be the cubed root of 729 over the cubed root of 1331. So we're just going to type those individually into our calculators. Remember to do the cubed root, at least on the calculators that we use, you do 3 second x root, so it pops up as the cubed root, 729, enter. For A, that gives me 9. Then we do the cubed root, 3 second x root 1331. That's going to give me 11. So my A is 9, my B is 11. So how do I find A squared over B squared for that middle level? That's going to be 9 squared over 11 squared. 9 squared is 81. 11 squared is 121. So that is my surface area ratio. So similarity ratio is 9 over 11, that's A over B. 81 over 121 is my A squared over my B squared. And then A cubed over B cubed for the volume is 729 over 1331. All right, the next set of directions say, given the surface area of two similar figures, solve for the unknown volume. So no longer do we have a picture, but we do have the same process over here where we have our A over B for similarity ratio, A squared over B squared for surface area, and A cubed over B cubed for volume. Okay? And we're going to use one of those in a minute once we find those ratios to find an unknown volume. So it says that the surface area of each figure is given. So what information is given on both as far as numbers that are filled in? Surface area. So that's going to be my A squared over my B squared is what I can fill that in for. So that's going to be 425 over 1088. We're going to reduce that fraction. 425, 1088 reduces to 25 over 64. And that is going to be my surface area ratio, which is level 2, 25 over 64. How do I use that to go to level 1? Well, if I'm going from squared to A squared to just A, I'm going to take the square root of 25, that's the inverse of squaring, and the square root of 64. So the square root of 25 gives me 5 for A, square root of 64 gives me 8 for B. So I've got similarity ratio level 1, surface area ratio level 2, and I just need to unlock level 3. So how do I do that? I take my A and B, which are 5 and 8, and I do 5 to the third power over 8 to the third power. 5 to the third power is going to give me 125. 8 to the third power is going to give me 512. So that is no different than what we've done so far. What's new is it says, given the surface area of two similar figures, solve for the unknown volume. So which ratio do I need to work with when I'm working with volume? That is going to be this ratio, 125 over 512. So I know that whatever the actual volumes are, they should reduce to the ratio of 125 over 512. So which volume do I know? I don't know the first volume. I don't know the smaller volume, but I do know the bigger volume. Whatever the original smaller volume is, over 13,312, should reduce to the ratio of 125 over 12. So we are just going to cross multiply and we are going to solve. So when we cross multiply, that is going to be V times 512 equals 13,312 times 125. So that is going to give me 512 V equals 13,312 times 512 is a big number, 15744. 13,312 times 125. I'm so sorry, y'all. That's way bigger of a number than I anticipated. Here we go. I'm going to do 13,312 times 125 times 125. That's going to give me this number. Let's see, 1,664,000. So that is going to give me 1,664,000. I'm going to divide that by 512. Just cross multiplying here. And when I divide that by 512, I'm going to get a volume of 3,250. And my units are going to be, volume is in km cubed, so kilometers to the third power. So I just found my unknown volume using the ratio. All right, let's do another one of those. So we are given our surface area ratios. So what is surface area? Surface area is going to be A squared over B squared. So I'm going to fill in 94 over 846. 94 fraction button 846, that will reduce that for you in your calculator. If you're not sure how to do that, let me know. Come see me. 1 over 9. And so I put that on, here's A over B. Surface area is A squared over B squared. Volume is A cubed over B cubed. So I'm going to put that on level 2 because that's my surface area ratio, 1 over 9. So how do we go from A squared over B squared to just A over B? That's going to be the square root of 1 over the square root of 9, which we know is going to be 1/3. And then when I want to get level 3, I'm going to go 1 cubed over 3 cubed for my volume ratio. That is going to give me 1 over 27. So I'm going to use those ratios, and I'm going to use one of those ratios to find a volume, a missing volume. So we're missing that first volume. And so we're going to work with our volume ratio. Whatever the actual volume is should reduce to 1 over 27 when I compare them. So I'm going to do V over 1620, and I'm going to cross multiply. So I'm going to do V times 27 is going to give me 27V. Goodness gracious, y'all. Hold on one second. There we go. 27V is going to be equal to 1 times 1620, which is 1620 when I cross multiply. And so what I'm going to end up doing is dividing by 27 on both sides. And so when you do 1620 divided by 27, you're going to get 60. So my volume is going to be 60. What are my units? Meters cubed. So that smaller volume is going to be 60 meters cubed. All right. Now let's do the same thing, but instead of starting with surface area, let's start with given volume. So given the volume of two similar figures, solve for the unknown surface area. So same as before, we've got our similarity ratio, our surface area ratio, and our volume ratio. And we're going to use that to find an unknown surface area. So this time we're given our volume, and so 27 and 125. So that's going to be A cubed over B cubed. 27 over 125 does not reduce, so I get to go ahead and fill that in. It's going to be 27 over 125. To get back to my A over my B, level 1, I'm going to take the cubed root of both of those. So the cubed root over 27 over the cubed root of 125. So that is going to give me 3 over 5, 3/5. And what does that mean for my surface area ratio? I'm going to square both of those. So 3 squared over 5 squared, A squared over B squared, is going to give me 9 over 25. So here are my 3 ratios. That's the first part of the question. And now we have to decide which of those do I use to find an unknown surface area. So I want to find the bigger surface area. And so I'm going to put an X there. We're going to do 63 over X should be equal to which of these fractions? Well, the surface area ratio is 9 over 25. So I'm going to set that equal to 9 over 25. And then I'm just going to cross multiply like before. So I'm going to cross multiply. You get 9 times X is equal to 9X. You set that equal to 63 times 25, which is 1575. And then you divide by 9. And when you do that, you get that X is 175. That is bigger than 63 like I expected, and that's going to be inches to the second power. So 175 inches to the second power. All right, one more time. We're given volumes. So that's going to be my A cubed over my B cubed. So A cubed over B cubed is going to be 384 over 10,368. I'm going to reduce that, or at least see if it reduces, 10,368. It does reduce. That reduces way down to 1 over 27. So I'm going to fill that in for my volume ratio. So that's going to be A cubed over B cubed. That's 1 over 27. To get back to my A over B, I'm going to take the cubed root because I'm going from something that is cubed to something that is not cubed. So I'm going to take the cubed root. So that's going to be the cubed root of 1 is 1. And then the cubed root of 27. Again, you type that in on your calculator. And that's going to be 1 over 3. And so then what we're going to do is we're going to find our surface area ratio where you take A and B, which are 1 and 3, and you square them, 1 squared over 3 squared. That is going to give me 1 over 9. So there are my 3 ratios, similarity ratio, surface area ratio, and volume ratio. We're going to use those in order to find an unknown surface area. So which one do we work with? We're going to work with our surface area ratio. So 1 over 9 is my surface area ratio. I know the volume of the smaller. I do not know the volume of the larger. So I'm going to do 3,168, and I'm going to just put an X there over X. So small to large. So I'm just going to put an X. And again, we're just going to cross multiply. And so whenever you cross multiply, you get 1 times X is X. And it's going to be 9 times bigger. So 9 times 3,168. That is going to give me a surface area of 28,512. My units are inches squared. So 28,512 inches squared is what that surface area is given these ratios. So we were able to find the surface area of a shape without knowing any of its dimensions, just based on these ratios. And so your homework is on the back. Come see me if you're having issues with your calculator. I am happy to help you, especially if you're working with one that is not the same as ours as far as lining up with the buttons. I'm happy to help you with that.